Hi, welcome to this video. In this video I'm going to be going over the slope of tangent lines and normal lines. So by the end of this video, hopefully you should be able to determine the slope and the equation of a line tangent to the curve as well as the normal line using the power rule. So I'm going to stick to the power rule ones. Alright. So what you need to know is that the derivative is one of the ways that we use the derivative is to find the slope of the tangent line. So here's a graph here. And this is our function. We'll just call this y equals f of x. And our tangent line here is at the point 1, 1. So this is the point 1, 1. 1, 1. The slope of this line, so the slope of the line tangent to this is going to be the derivative. So the derivative, if this is f of x, the derivative of x at 1 is equal to the slope of the tangent line. Slope of the tangent line at x equals 1. So if I have a function y equals f of x, f prime of a is the slope of the tangent line at x equals a. So if I'm looking for the slope of the tangent line or the equation of the tangent line to any point on this curve, all I would have to do is find the derivative and plug in my value of a, and that would give me my slope of the tangent line. Let's take a look at an example. So let's determine the equation of the line's tangent and normal, and I'll talk about normal just real quick, what normal is in just a second, to the function at the given point. So we have this function and we're going to find the tangent line at this point. Remember that a line tangent to a curve is a line that crosses the curve once, so it touches it at one point. So we're going to find the derivative. So the first thing we do is find the derivative, y prime. We're going to use a power rule, so 2 times 4x, so subtract 1, minus the derivative here is 3, and the derivative of 1 is 0. So this is my derivative, and I'm going to plug in x equals 2. Okay, so I'm going to plug in 2 for x here. And let me make this clear that I'm not putting it in the power here. Okay, y prime of 2 is equal to 4 times 2 minus 3, which is 8 minus 3, which is 5. So this is my slope of the tangent line. If I wanted to find the equation of the tangent line, which is what I want to do, I'm going to use the form, the point slope form, y minus y1 equals m times x minus x1. So I'm going to plug in y1, which is 3, m, which is 5, we just found m, and x, which is 2, and this is our equation. Now we can simplify that if we wanted to. Y minus 3 equals 5x minus 10. So in slope-intercept form, that's 5x minus 7. All right, so this is the slope of the tangent line. Okay, I left a lot of space here because I'm going to show you the normal line. All right, so the normal line is the line that's perpendicular. Oops. It's perpendicular to the tangent line. Okay, and that's called the normal line. So the slope of the normal line is going to be, and I use the upside down t to be perpendicular, is going to be negative 1/5, because remember the slope of any perpendicular line is the negative reciprocal of the line that we were using to begin with. So we're going to use y minus y1 equals m times x minus x1. We're always going to use this one. And y1 is 3, m is negative 1/5, and x1 is 2. If we want to simplify this here to slope-intercept form, we're going to add 3/5, 3. Okay, we're going to add 3 to both sides here. So I distribute and then add 3. And I get y equals negative 1/5 x plus 17/5. Okay, so this would be my equation of the normal line. All right, that's about it. I'm only going to stay on power rule here. So really we're looking at doing a few things. All you need to do is take the derivative, plug in your value for x, and then use the point slope form to find your equation. Let's do one more here. And this time we've got something a little, should be an E here. We've got an example that's a little trickier. Determine the points on the curve, this is the curve, where the tangent lines are horizontal. So remember that horizontal lines, the slope of horizontal lines is 0. So what we're going to do is we're going to take the derivative. Okay, whenever we see tangent lines, we think need to take a derivative. So derivative here is 6x squared minus 5 halves times x squared is times 2 is 5. Subtract 1x minus 4. Okay, and then we're going to say, where is this slope? Where is this slope equal to 0? Well, we're going to solve this for x. So we're just going to solve this, and that's going to be, I think this is going to factor to 2x plus 1 and 3x minus 4. Solve for x here. We get x equals negative 1/2 and y equals 4/3. I'm sorry, y. What am I talking about? The other x value is 4/3. And what we're going to want to do is we're going to want to find the points. So we're going to plug in x's into our formula, our equation here, and we're going to find out what our y value is. So y equals 2 times negative 1/2 cubed minus 5 halves squared minus 4 times 1/2 plus 1. So this is going to be negative 1/4 minus 5/4 minus 2 plus 1, which is negative 6/4 minus 1. That's going to be 3 halves. Negative 3 halves minus 1, which is negative 5 halves. So my point is going to be negative 1/2 comma negative 5 halves. Yeah, sounds like I got a text message. So that's one of the points. Our other point, we're going to plug in 4/3. Times 4/3 minus 4 times 4/3. And with the little help of our little calculator here, so do a little less work, I've got negative 109/27. Alright, so my points are 4/3 comma negative 109/27 and a negative 1/2 5 halves. Okay, so let's look at that was it. Those are my two examples. You can try a practice problem here, and if you just pause it right now, I'll give you the solutions after you paused. Okay, here's the solution. So y prime equals negative 9x squared plus 2x plus 3, and I'm going to plug in negative 1 in here. So negative 9 times negative 1 squared plus 2 times negative 1 plus 3, which is negative 9. Ooh, negative 9. Yep, that's right. Negative 9 minus 2 plus 3, which is negative 8. So y minus 2 equals negative 8 times x plus 1. And you know, you can actually leave it this way. This would be the tangent, and the normal would be 1/8. And that's the normal line. Okay. Alright, that's it for this video. See you later.